Close your eyes and imagine floating in the gentle darkness of space. You are drifting peacefully between the planets. Around you, the cosmic garden stretches endlessly in every direction. This garden is unlike any you have ever seen. Instead of flowers and trees, it grows with ancient stones. These stones have been traveling through space for billions of years. They are called asteroids. They move in slow, patient orbits around our sun. Picture these wandering mountains as they glide silently through the void. Some are as small as cars. Others are larger than entire cities. They tumble slowly end over end. Their surfaces are scarred and weathered by countless years in space. You might wonder what makes these floating rocks so special. The answer lies hidden within their ancient hearts. These asteroids are like treasure chests that have been locked away in space since the very beginning of our solar system. Long ago, when the planets were still forming, these stones collected precious materials. They gathered metals that are incredibly rare on Earth. Platinum gleams within their rocky cores. Gold waits patiently in their depths. Rare earth elements rest quietly in their crystalline structures. One single asteroid might contain more platinum than has ever been mined on our entire planet. Imagine that for a moment. A mountain floating in space could hold enough precious metal to supply Earth's needs for thousands of years. As you drift through this cosmic garden, you begin to notice the different types of asteroids around you. Some appear dark and carbon-rich. These are like the soil of space. They contain water frozen as ice and organic compounds that could fuel future space missions. Others gleam with a metallic shine even in the dim sunlight. These are the metal-rich asteroids. They are the true treasures of the cosmic garden. Their surfaces hint at the wealth contained within. Iron and nickel form their foundations. But scattered throughout are veins of the most precious materials in the universe. Scientists have given these celestial treasures names that sound almost poetic. The M-type asteroids are the metal-rich giants. The C-type asteroids are the carbon-rich wanderers. The S-type asteroids blend stone and metal in perfect harmony. You float closer to one particularly interesting asteroid. It spins slowly before you like a giant, irregular planet. Its surface tells the story of billions of years in space. Craters mark where smaller stones have struck it. Bright streaks show where impacts have exposed fresh material beneath. This single asteroid, you realize, could change everything about life on Earth. The metals within its core could power our technology for generations. The rare elements it contains could enable discoveries we can barely imagine today. But these treasures are not easy to reach. They drift in the cold emptiness between worlds. The closest asteroid might be millions of miles away from Earth. Others travel in paths that take them far beyond the orbit of Mars. The cosmic garden operates on a different timescale than earthly gardens. These stone fruits take years or decades to ripen into positions where human technology might reach them. We must wait patiently for the right moment when their orbits bring them close enough to harvest. As you continue floating through this celestial orchard, you notice something remarkable. The asteroids seem to be organized in loose families. Some cluster together in a region between Mars and Jupiter called the asteroid belt. Others follow paths that bring them closer to Earth. The asteroid belt is like the main orchard of the cosmic garden. Hundreds of thousands of asteroids drift there in a loose collection. They maintain a respectful distance from each other as they orbit the Sun. Each follows its own unique path through space. But some asteroids are more adventurous. They follow paths that bring them closer to our planet. These are called near-Earth asteroids. They are the low-hanging fruit of the cosmic garden. They offer the most promising targets for future mining missions. Picture yourself moving among these near-Earth asteroids. They pass by our planet like cosmic visitors making regular rounds. Some complete their journey around the Sun in just a few months. Others take several years to return to our neighborhood. Each of these wandering mountains carries its own unique treasure. Some are rich in platinum and palladium. Others contain rare earth elements essential for modern electronics. A few might even carry enough water ice to fuel entire space missions. The cosmic garden has been growing these treasures for over 4 billion years. While Earth was developing its first oceans and primitive life, these asteroids were collecting and concentrating precious materials. They have been patient gardeners, slowly accumulating wealth in the silent darkness of space. Now, as you float peacefully among these ancient stones, you can almost feel their quiet potential. They represent not just mineral wealth, but a new chapter in human exploration. They offer resources that could power our expansion into the solar system. The cosmic garden stretches endlessly around you. Each asteroid is a seed of possibility. Each carries the potential to transform human civilization. They wait patiently in their eternal orbits, ready to share their ancient treasures. As your journey through this celestial orchard continues, you begin to wonder about the practical questions these floating treasures raise. If an asteroid contains enough platinum to supply Earth for 1,000 years, who has the right to claim such wealth? Let your mind settle on a single asteroid drifting peacefully through space. This mountain that never landed on any world holds secrets that would make ancient treasure hunters weep with wonder. Picture this wandering stone as it tumbles slowly through the darkness. It is roughly the size of a small city. Its surface appears grey and unremarkable in the dim sunlight. But within its ancient heart lies wealth beyond imagination. Scientists have studied this particular asteroid using powerful telescopes. They have given it a simple name, 16 Psyche. But there is nothing simple about what it contains. This mountain holds more precious metal than has ever existed in all of human history. Imagine for a moment the weight of such treasure. If you could somehow bring this entire asteroid to Earth, its metals would be worth more than the combined economies of every nation on our planet. The number is so large it becomes almost meaningless. Quadrillions of dollars in a single floating mountain. But what makes this space rock so incredibly valuable? The answer lies in how our solar system formed billions of years ago. When planets were still young and molten, the heaviest metals sank toward their centers. Gold, platinum, and other precious materials settled deep into planetary cores. On Earth, these metals are buried thousands of miles beneath our feet. We can only find tiny amounts that have been brought to the surface by volcanic activity or cosmic impacts. This is why gold and platinum are so rare and precious on our world. But asteroids like Psyche tell a different story. They are fragments of ancient worlds that never quite became planets. When these early worlds were destroyed by cosmic collisions, their metal-rich cores were scattered into space. The asteroids we see today are the surviving pieces of those shattered planetary hearts. Picture Psyche floating serenely in its orbit between Mars and Jupiter. This mountain is essentially a planetary core that has been exposed to space. All the precious metals that would normally be hidden deep inside a world are right there on the surface, waiting patiently in the cosmic darkness. The amount of platinum in Psyche alone could supply Earth's needs for millions of years. There is enough gold in this single asteroid to give every person on our planet several pounds of the precious metal. The rare Earth elements it contains could power our technology for countless generations. But Psyche is not alone in its cosmic wealth. Throughout the asteroid belt, similar treasure mountains drift in their ancient orbits. Each tells the story of worlds that might have been. Each carries the concentrated wealth of planetary formation. Consider a smaller asteroid, one only a few hundred feet across. Even this modest space rock might contain more platinum than all the mines on Earth have ever produced. A single mining mission to such an asteroid could bring back enough precious metals to transform our entire economy. The metals in these asteroids formed under conditions that no longer exist in our solar system. They were created in the hearts of ancient stars and forged in the crucible of planetary birth. Each gram of platinum tells a story that spans billions of years. You might wonder why these metals are so valuable to us. Platinum is essential for many modern technologies. It helps clean the exhaust from cars and trucks. It makes possible the fuel cells that could power our future energy systems. It is crucial for many medical devices and treatments. Gold, beyond its beauty and traditional value, is one of the best conductors of electricity. As our electronics become smaller and more sophisticated, we need gold for computer chips and circuits. The demand for these metals grows every year, while Earth's supplies remain limited. Rare earth elements tell an even more compelling story. Despite their name, they are not actually rare in space. Asteroids contain vast quantities of these materials that are essential for modern life. They power our smartphones and computers. They make possible the magnets in wind turbines and electric car motors. On Earth, mining these materials is difficult and often harmful to the environment. The processes required to extract and refine them can damage landscapes and pollute water supplies. But in space, these same materials float freely in the vacuum, waiting to be collected without environmental cost. Picture the gentle process of space mining. Robot spacecraft approach an asteroid like patient gardeners. They use solar energy to power their tools. There is no atmosphere to pollute, no ecosystems to disturb. The extraction happens in the perfect silence of space. The metals they collect are already purified by billions of years in the vacuum of space. There are no impurities to remove, no toxic chemicals needed for processing. The treasure comes pre-packaged by the cosmos itself. A single successful asteroid mining mission could bring back enough precious metals to crash the prices of these materials on Earth. What was once rare and expensive could become common and affordable. This abundance could revolutionize technology and improve life for everyone. Imagine a world where platinum is as common as aluminum. Where gold is so plentiful it could be used in everyday electronics without concern for cost. Where rare earth elements are truly common, enabling technologies we can barely dream of today. But this abundance raises profound questions. If a single asteroid contains enough wealth to dwarf entire national economies, who should own such treasure? How do we decide who has the right to claim these floating mountains of precious metals? As you drift in your thoughts between sleep and waking, consider the gentle irony of cosmic abundance. Above your resting form, mountains of treasure circle the sun in patient orbits, waiting for the moment when humanity learns to reach them and wondering who among us will decide their fate. Float with me now into the realm of invisible lines drawn across the darkness of space. Here, where no fences can stand and no borders can be marked, humanity has tried to create order from the infinite. Picture the vast emptiness between worlds. There are no roads here, no signposts, no walls to mark where one territory ends and another begins. Yet somehow, we have attempted to divide this endless ocean of space into parcels that nations might claim. The story begins back on Earth, in the year 1967. World leaders gathered to sign a document called the Outer Space Treaty. They were worried about the Cold War extending beyond our planet. They wanted to prevent space from becoming another battlefield between competing nations. These diplomats, sitting in comfortable rooms far from the cosmic void, wrote words that would echo across the solar system. They declared that no nation could claim ownership of the moon or any other celestial body. Space, they decided, belonged to all humanity. The treaty was like trying to organize an infinite library where every book floats freely and no shelves exist. The leaders meant well, but they were writing rules for a realm they had never visited. They were creating laws for treasures they had never seen. Imagine the elegant simplicity of their main idea. Space was to be the province of all mankind. No country could plant a flag on an asteroid and call it their own. No nation could draw borders around planets or moons. The cosmos would remain free and open to everyone. But the treaty writers in 1967 could not have imagined the treasure mountains we now know drift through space. They thought of space exploration as a matter of science and national pride. They did not dream of asteroids filled with enough platinum to power civilizations. Picture yourself floating beside one of these valuable asteroids. According to the Outer Space Treaty, this mountain of precious metals belongs to no one and everyone at the same time. It is part of the common heritage of mankind. Yet this creates a gentle puzzle that grows more complex each year. If no one can own an asteroid, who has the right to mine it? If the metals belong to all humanity, how should the profits be shared? These questions drift through space like cosmic riddles waiting for answers. The treaty says that space activities must benefit all countries, regardless of their level of development. This means that wealthy nations with advanced space programs cannot simply claim the best asteroids for themselves. The benefits must somehow reach everyone on Earth. But how does this work in practice? Imagine a company spending billions of dollars to send robots to an asteroid. They risk their investment, their technology, their years of planning. When their mining mission succeeds, must they share all the profits with every nation on Earth? The legal scholars who study space law are like gardeners trying to tend a garden that exists in multiple dimensions. They must consider not just the words of treaties, but the practical realities of cosmic engineering. Their work happens at the intersection of dreams and physics. Some countries have begun to interpret the old treaty in new ways. They argue that while you cannot own an asteroid itself, you can own the materials you extract from it. This is like saying you cannot own a wild apple tree, but you can own the apples you pick from its branches. The United States passed a law in 2015 that allows American companies to keep the resources they mine from asteroids. Luxembourg, a small European nation, has created similar laws. These countries are essentially saying that cosmic treasure belongs to whoever can reach it first. But other nations worry about this interpretation. They fear that only wealthy countries with advanced space programs will benefit from asteroid mining. The cosmic commons might become divided among the few nations rich enough to reach them. Picture the delicate dance of international diplomacy as it extends into space. Countries must balance their desire for cosmic wealth with their commitments to share space's benefits. They must write new laws for an environment where old concepts of ownership become as weightless as the asteroids themselves. Some legal experts suggest creating an international space mining authority. This organization would be like a cosmic librarian, keeping track of who is mining which asteroids and ensuring that some benefits flow to all nations. They would manage the treasure mountains of space as a shared resource. Others propose that asteroid mining companies should pay a percentage of their profits into a global fund. This fund could support development projects on Earth or finance space exploration for countries that cannot afford their own programs. The wealth of space would trickle down like cosmic rain. But enforcing space law is like trying to patrol an ocean that has no shores. How do you monitor mining operations that happen millions of miles from Earth? How do you resolve disputes between nations when the courthouse is on one planet and the crime scene floats in the void? The questions grow more complex as technology advances. Soon, private companies will have the ability to reach asteroids and extract their treasures. These companies operate for profit, not for the benefit of all humanity. How do we ensure that cosmic wealth serves the common good? Consider the gentle irony of our situation. We have created elaborate laws to govern the ownership of objects we cannot yet reach. We have written detailed regulations for industries that do not yet exist. We are organizing a cosmic economy before we have learned to participate in it. The invisible boundaries we draw in space are more like guidelines than walls. They exist in treaties and legal documents, not in the physical reality of the cosmos. They depend on cooperation and goodwill rather than enforcement and punishment. As you drift deeper into sleep, imagine these invisible lines stretching across the solar system like the finest spider webs. They connect our earthly concepts of law and ownership to the infinite realm of space. They represent humanity's attempt to bring order to chaos, fairness to abundance. But even as we create these cosmic legal frameworks, new questions emerge. Who will enforce these invisible boundaries when the first mining ships launch toward their distant targets, and what happens when human ambition meets the patient reality of space? In quiet laboratories and engineering workshops around the world, modern prospectors are preparing for the greatest treasure hunt in human history. These are not the rough miners of old, with pickaxes and shovels. These are scientists and engineers, working with computer models and robotic prototypes. Picture them in their clean, bright workspaces. They wear lab coats instead of mining helmets. Their tools are keyboards and blueprints rather than dynamite and drills. But their dreams are just as bold as any gold rush pioneer who ever crossed a mountain range seeking fortune. These prospectors of tomorrow face challenges that would have amazed the miners of centuries past. Their treasure lies not across a continent, but across the vast emptiness of space. The journey to their claims takes not weeks or months, but years. The environment they must work in would kill them instantly without protection. Yet they persist with the same patient optimism that has driven treasure seekers throughout history. They know that the rewards waiting in space dwarf anything ever found on Earth. A single successful mission could yield more wealth than all the gold rushes combined. Watch them as they design their robotic miners. These machines must be able to survive the journey to an asteroid and work autonomously for months or years. There are no repair shops in space, no spare parts available for delivery. Every component must be perfect before it leaves Earth. The robots themselves are marvels of engineering poetry. They move with solar-powered grace, their panels spread like metallic wings to catch the distant sunlight. Their bodies are built to withstand temperature swings that would shatter most earthly machines. From scorching heat when facing the sun to bitter cold in shadow. Each robotic prospector carries within its memory the accumulated knowledge of human civilization. It knows how to identify valuable materials, how to extract them efficiently, how to process them for the journey home. It is simultaneously miner, refinery, and transport vehicle. The engineers who design these cosmic prospectors work with the precision of watchmakers and the vision of poets. Every gram of weight matters when launching into space. Every component must serve multiple purposes. Elegance becomes not just beautiful, but essential for survival. Consider the gentle ballet these machines must perform. They approach an asteroid moving at thousands of miles per hour, matching its speed and rotation with mathematical precision. They anchor themselves to the surface with barely perceptible touches, like butterflies landing on flowers. The mining process itself is unlike anything attempted on Earth. There is no gravity to help machinery work, no atmosphere to carry away dust and debris. The robots must create their own gentle breezes using electric charges to collect the precious particles they extract. Some prospectors dream of using focused sunlight to melt asteroid surfaces, creating pools of liquid metal that can be easily collected. Others envision magnetic fields that can separate valuable materials from worthless rock. Each approach requires technologies that exist only in imagination and early prototypes. The companies preparing for asteroid mining have names that sound like poetry. Planetary Resources, Deep Space Industries, Moon Express. Their founders are often former aerospace engineers or technology entrepreneurs who grew tired of earthly limitations. These modern prospectors raise money not from individual investors, but from venture capital firms and government agencies. Their business plans read like science fiction novels, describing operations that will span decades and require technologies not yet invented. Picture the mission control rooms where these space prospectors will monitor their robotic miners. Walls covered with screens showing asteroid orbits, mining progress, and the slowly accumulating treasure. Engineers working in shifts around the clock, nursing their distant robots through challenges no earthly miner has ever faced. The timeline for asteroid mining stretches like a gentle river toward the future. The first missions are planned for the late 2020s and early 2030s. These will be small demonstration projects, proving that the technology works and the treasures are real. But the real prizes will come later, as technology improves and costs decrease. By the 2040s, regular cargo ships might be returning from asteroid mines, their holds full of precious metals. The space around Earth could become busy with traffic between our planet and the treasure mountains beyond. The prospectors of tomorrow understand that they are not just seeking wealth, but opening a new frontier for human civilization. The resources they extract from asteroids could power our expansion into the solar system. The technologies they develop could solve problems we have not yet imagined. Some of these cosmic prospectors are not seeking financial rewards at all. They are driven by the same curiosity that has always pushed humans to explore new territories. They want to know what lies beyond the next hill, even when that hill is floating in space millions of miles away. The challenges they face would discourage most earthly entrepreneurs. The technical hurdles are immense. The financial risks are staggering. The timeline for return stretches far beyond normal business planning. Yet they continue their patient work, driven by visions of abundance. Watch them test their prototypes in laboratories that simulate the harsh conditions of space. Vacuum chambers where robots learn to work without air. Temperature chambers where components face the extreme cold of the cosmic void. Radiation chambers where electronics must survive the harsh environment beyond Earth's protective magnetic field. Each test brings them closer to the day when their mechanical prospectors will launch toward distant asteroids. Each successful experiment proves that the impossible is merely difficult. Each failure teaches lessons that bring success closer. The modern prospectors work not with the desperate urgency of gold rush miners, but with the patient determination of gardeners planting seeds for future harvests. They know their robots may work for years before returning any treasure to Earth. As you drift toward sleep, imagine these quiet pioneers in their laboratories, solving problems that have never existed before. Their work continues through the night, as steady and persistent as your own breathing, preparing humanity's first steps toward harvesting the infinite wealth that waits patiently among the stars. Picture a robotic mining spacecraft approaching its distant target. The machine moves through space with the fluid grace of a whale swimming through deep ocean currents. Its solar panels spread wide like metallic wings, drinking in the pale sunlight that has traveled millions of miles to reach this remote corner of the solar system. The asteroid tumbles slowly ahead, a mountain of ancient rock and metal spinning gently in the cosmic void. The robot watches patiently, calculating the perfect moment to begin its delicate approach. There is no hurry here. Time moves differently in the vast emptiness between worlds. As you watch this celestial ballet unfold, notice how the robot moves without sound. In the vacuum of space, there are no engines roaring, no machinery clattering. The spacecraft adjusts its position using tiny puffs of gas, like a dancer making subtle shifts in weight and balance. The robot carries within its metal body the accumulated wisdom of human engineering. Every circuit and sensor has been designed to work flawlessly in an environment where repair is impossible. It must be surgeon and patient, artist and canvas, all at once. Watch as the mining robot extends delicate sensors toward the asteroid's surface. These instruments can taste the chemical composition of rock from a distance, identifying veins of precious metals hidden within the ancient stone. They work like electronic bloodhounds, following the scent of platinum and gold. The approach to the asteroid takes hours, even days. The robot must match not only the asteroid's speed through space, but also its slow tumbling rotation. It is like trying to board a carousel that spins once every few hours while both rider and ride hurtle through an infinite dance hall. When the robot finally reaches the asteroid, it extends mechanical arms that touch the surface with the gentleness of a butterfly landing on a flower. Tiny harpoons anchor it to the rock, creating the first physical connection between human technology and this wandering mountain of treasure. Now the real dance begins. In the absence of gravity, the robot must create its own choreography. Every action produces an equal and opposite reaction. Push against the asteroid, and both robot and rock will move apart. The machine must learn to work with physics as a partner, not an opponent. The mining tools themselves are marvels of engineering poetry. Some use focused beams of sunlight, concentrated through mirrors and lenses to create temperatures hot enough to melt rock. The robot becomes a cosmic sculptor, using starlight as its chisel to shape and extract precious materials. Other tools work more gently, using electric charges to lift particles of valuable dust from the asteroid's surface. The robot creates its own small weather system, generating tiny lightning storms that separate precious metals from worthless stone. The valuable particles drift upward like metallic snow falling in reverse. Watch the robot work through the long days and nights of space. There is no sunrise or sunset here, only the steady presence of distant stars and the gentle warmth of the sun's rays. The machine works with infinite patience, never tired, never bored, never discouraged by the slow pace of progress. The extracted materials must be carefully collected and stored. In zero gravity, every flake of precious metal wants to float away into the cosmic void. The robot uses magnetic fields and electric charges to gather its harvest, like a farmer using invisible nets to catch falling grain. Some mining robots work alone, like solitary artists creating masterpieces in the vast gallery of space. Others work in teams, their movements coordinated by radio signals that travel at the speed of light between Earth and their distant workplace. They share information and divide tasks with the efficiency of bees working in a hive. Picture the robot solar panels slowly tracking the sun as the asteroid rotates. The panels move like sunflowers following daylight, always seeking the optimal angle to capture the energy needed for mining operations. When the asteroid's rotation carries the robot into shadow, work slows but never stops entirely. Batteries store enough power to continue the patient harvest. The most advanced mining robots can even begin processing their harvest while still in space. They become floating refineries, using the extreme cold and vacuum of space as tools for purification. Metals that require enormous energy to separate on Earth can be divided naturally in the harsh environment of space. The robot's work creates its own gentle rhythm. Extract, collect, process, store. Extract, collect, process, store. The pattern repeats endlessly, as steady and reliable as your own heartbeat. Each cycle brings a few more grams of precious material closer to eventual return to Earth. Communication with these robotic miners happens at the speed of light, but even light takes many minutes to cross the gulf between Earth and the asteroid belt. Mission controllers must send instructions and then wait patiently for responses. It is like having a conversation with echoes that take 20 minutes to return. The robots learn to make their own decisions during these communication delays. They must be independent enough to handle unexpected situations, yet reliable enough to follow their programming for months or years without human intervention. They embody the best qualities of both artist and engineer. As the mining operation continues, the robot gradually transforms the asteroid's surface. What was once a smooth, weathered stone becomes pocked with small excavations and collection points. The robot is writing its story directly onto the ancient rock, creating the first human-made changes to objects that have remained unchanged for billions of years. The dance between robot and asteroid becomes increasingly intimate over time. The machine learns the asteroid's moods and movements. It discovers which areas are rich in valuable materials and which are better left alone. Like a careful gardener, it harvests selectively, leaving the asteroid's basic structure intact. Some mining robots are designed to work for years before returning their treasure to Earth. Others prepare their harvest for pickup by specialized transport ships. Each approach creates its own choreography, its own pattern of patient work in the cosmic darkness. The robot sensors constantly monitor its own health and the progress of mining operations. It reports back to Earth with the dedication of a faithful servant, sending streams of data across the void to update its human creators on the slow accumulation of cosmic wealth. As you imagine these mechanical dancers working in the silence between worlds, consider the gentle irony of their situation. These most sophisticated machines ever built work in the most primitive environment imaginable, using starlight and ancient rock to create wealth that will transform the civilization that sent them into the darkness. Imagine waking up one morning to discover that gold has become as common as seashells on a beach. Picture a world where platinum costs no more than aluminum, where rare earth elements are truly as abundant as their name suggests they should be. This is the gentle revolution that asteroid mining might bring to our sleeping planet. For thousands of years, human civilization has been shaped by scarcity. We have fought wars over patches of land rich in oil or precious metals. We have built entire economies around the simple fact that valuable things are hard to find and difficult to extract. But space offers a different story entirely. Consider how our ancestors valued salt so highly that Roman soldiers were sometimes paid in it. The word salary comes from this ancient practice. Salt was precious because it was scarce and essential. But when new sources were discovered and better ways to produce it were developed, salt became common. The salt wars ended not with victory or defeat, but with abundance. Asteroid mining promises to do for precious metals what new salt sources did for that ancient commodity. A single metallic asteroid might contain more platinum than has ever been mined on Earth. Imagine the ripple effects of such abundance flowing gently through our economic systems like water finding new channels. Picture the factories that could be built if rare earth elements were truly common. These materials are essential for making solar panels, wind turbines, and electric car batteries. When they become abundant, clean energy technology could spread across the world like flowers blooming in an endless spring. The smartphone in your pocket contains tiny amounts of dozens of rare elements. Each phone requires materials gathered from mines scattered across multiple continents. But when these elements flow freely from space, the cost of technology could drop like autumn leaves, making advanced devices available to everyone on Earth. Think about the gentle irony of cosmic abundance. The very emptiness of space, which seems so barren and lifeless, actually contains more wealth than all the treasures ever found on our green and living planet. The void between worlds is filled with mountains of riches waiting patiently to transform human civilization. But abundance brings its own challenges, as gentle as they may be. Entire industries built around scarcity would need to find new purposes. Mining companies that have spent generations extracting metals from Earth might need to become space logistics companies instead. The transformation would be gradual, like seasons changing, but profound. Consider the nations whose economies depend on mining and selling precious metals. South Africa mines much of the world's platinum. Russia and other countries extract large amounts of rare earth elements. When these materials become abundant through asteroid mining, these nations would need to discover new economic foundations. Yet this transformation could bring unexpected benefits. Countries that have never had access to precious metals might suddenly find themselves able to build advanced infrastructure. The global economy could become more balanced, like a scale finally finding equilibrium after centuries of tipping back and forth. Picture the research that could flourish when expensive materials become cheap. Scientists dream of experiments that require large amounts of rare elements but cannot afford them. With cosmic abundance, laboratories around the world could explore possibilities that are currently beyond reach. New discoveries might bloom like flowers after rain. The medical field could be transformed by abundant precious metals. Platinum is used in many life-saving devices and treatments, but its cost limits its availability. When platinum becomes common, these medical miracles could reach patients everywhere, spreading healing as widely as sunlight. Even our relationship with beauty might change. Gold and silver have been treasured for their rarity as much as their appearance. When these metals become abundant, we might discover new forms of beauty based on craftsmanship and design rather than scarcity. Art could flourish in ways we cannot yet imagine. The transition to cosmic abundance would happen gradually, like dawn breaking slowly across a landscape. The first asteroid mining missions would bring back relatively small amounts of material. Prices would drop gently rather than collapsing overnight. Markets would have time to adjust to the new reality. Financial systems would need to evolve to handle this new kind of wealth. Banks and investment firms built around scarcity would need to develop new models for abundance. The change would be as fundamental as the shift from barter to currency, but spread across decades rather than happening all at once. Picture the environmental benefits of cosmic abundance. Mining on Earth often scars landscapes and pollutes water supplies. When we can harvest metals from space, our planet could begin to heal. Old mining sites could be restored to natural beauty, like gardens reclaiming abandoned lots. The economics of infinity might seem like an impossible concept, but consider how dramatically economies have changed before. A medieval peasant could not have imagined the abundance of food in a modern supermarket. Our descendants might look back at our age of scarcity with similar wonder. Yet some things would remain precious even in an age of cosmic abundance. Clean air and water, healthy ecosystems, human creativity and love, these treasures cannot be mined from asteroids. They might become even more valued when material scarcity no longer dominates our attention. As you drift deeper into contemplation, imagine the gentle wave of change that cosmic abundance might bring. Like water slowly filling a vast basin, asteroid wealth could transform civilization without violence or disruption, simply by making the impossible possible and the rare commonplace. But as these economic transformations unfold across decades and centuries, questions arise about how such abundance should be shared fairly among the nations and peoples of Earth, and who should have the authority to make such momentous decisions for all humanity. Picture diplomats from around the world gathering in a quiet conference room to discuss the ownership of mountains they have never seen. These mountains float millions of miles away in the darkness of space. They have no flags planted on their peaks, no borders drawn across their surfaces, no governments to speak for them. The diplomats sit at polished tables beneath bright lights, their feet planted firmly on Earth's solid ground. Yet they are trying to create rules for a realm where there is no up or down, no solid ground, no borders that can be marked with fences or walls. They are writing laws for infinity. Each nation brings its own perspective to these gentle negotiations. Countries with advanced space programs see themselves as natural inheritors of cosmic wealth. They have invested billions in rockets and robotic technology. They argue that those who can reach the asteroids should have first claim to their treasures. But smaller nations raise their own quiet voices in these discussions. They point to the old space treaties that declared celestial bodies to be the common heritage of all mankind. They remind the room that space belongs to everyone, not just to those wealthy enough to build spaceships. Picture the delicate dance of international diplomacy as it extends beyond our atmosphere. Representatives must balance their nation's interests with the broader good of humanity. They must find ways to honor both ambition and fairness, both innovation and inclusion. Some countries propose creating international zones around valuable asteroids. These would be like cosmic parks, managed by international authorities for the benefit of all nations. Mining companies would pay fees to work in these zones, and the profits would be shared according to carefully negotiated formulas. Other nations suggest a different approach. They want to create space territories that mirror earthly boundaries. American companies would mine American asteroids. European companies would work European space claims. The cosmic wilderness would be divided like an invisible map drawn across the void. But how do you draw borders in space? On Earth, we use rivers and mountain ranges as natural boundaries. We mark invisible lines with fences and customs houses. In space, there are no permanent landmarks, no fixed reference points. Asteroids drift along curved paths that change slowly over thousands of years. Imagine trying to claim ownership of a cloud drifting across the sky. The asteroid you claim today might be in a completely different part of the solar system next year. The boundaries you draw must somehow account for the eternal dance of orbital mechanics. The negotiations reveal deep philosophical differences about the nature of ownership itself. Some cultures view land and resources as things that can be owned by individuals or nations. Others see natural wealth as belonging to the community, to be shared according to need rather than claimed by the powerful. These different worldviews meet and mingle in the conference rooms where space law is being written. Translators work not just with different languages, but with different concepts of property and community. They must find common words for ideas that some cultures do not recognize. Consider the gentle complexity of creating space agencies that represent multiple nations. The European Space Agency brings together countries that have sometimes been enemies on Earth. In space, old rivalries must give way to cooperation. Former adversaries become partners in the cosmic enterprise. The International Space Station orbits overhead as these diplomatic discussions continue below. It serves as a working example of what international cooperation in space might look like. Astronauts from different nations work side by side, sharing resources and knowledge in the weightless environment above national boundaries. But the space station is small compared to the asteroid mining operations being planned. Those future missions will involve billions of dollars in investment and potentially trillions in returns. The stakes are higher, the temptations greater, the need for clear agreements more urgent. Picture the signing ceremonies where these new space treaties might be finalized. Diplomats from around the world would put their names to documents that organize humanity's expansion into the solar system. Their signatures would create invisible lines of authority stretching across millions of miles of empty space. Yet even as treaties are signed, technology continues to advance. Private companies develop capabilities that were once limited to government space agencies. Billionaire entrepreneurs launch their own asteroid missions. The pace of technological change outstrips the careful deliberations of international diplomacy. Some nations try to extend their earthly laws into space through domestic legislation. They pass acts that allow their companies to keep whatever materials they extract from asteroids. They create space courts to resolve disputes between their cosmic mining operations. But what happens when space miners from different nations claim the same asteroid? When mining operations from competing countries arrive at the same treasure mountain on the same day? The vast distances of space make it impossible for earthly authorities to intervene quickly in such disputes. International lawyers work to create frameworks for resolving these cosmic conflicts peacefully. They envision arbitration panels that can make binding decisions about space disputes. They draft procedures for sharing information about mining plans and avoiding conflicts before they begin. The challenge becomes even more complex when private companies enter the picture. These businesses operate for profit, not for national glory or international cooperation. They make decisions based on market forces rather than diplomatic agreements. They answer to shareholders, not to treaties signed by governments. Some propose creating an international space mining authority with real power to enforce agreements. This organization would be like a cosmic police force, monitoring mining operations and ensuring that everyone follows the rules. But nations are reluctant to give up sovereignty to such an international body. Others suggest letting market forces solve the problems that diplomacy cannot. They argue that competing mining companies will naturally find ways to cooperate when cooperation serves their profits. Competition and collaboration would find their own balance in the cosmic marketplace. The questions multiply like stars appearing in a darkening sky. What happens when asteroid mining becomes profitable enough to influence elections on Earth? When space resources become so valuable that nations are tempted to use military force to protect their cosmic investments? These diplomatic challenges unfold slowly, like flowers opening in an infinite garden. Each agreement creates new questions. Each solution reveals new problems that require careful thought and patient negotiation. The work of organizing space continues day and night in conference rooms around the world. As you contemplate these gentle complexities of cosmic diplomacy, imagine the patient work of finding common ground between different nations and cultures. The same spirit of cooperation that might govern asteroid mining could offer hope for solving disputes here on Earth. But even as diplomats work to create frameworks for international cooperation, individual companies and entrepreneurs prepare to launch the first mining missions, racing to claim the treasures waiting in the darkness before any earthly agreements can catch up with their ambitions. Imagine a morning when the sky brings down its first gift of cosmic treasure. A small capsule descends through the atmosphere on a parachute, carrying metals more precious than any cargo that has ever returned to Earth. Inside this modest container lies wealth that could transform human civilization forever. The capsule lands gently in a desert, much like the spacecraft that carry astronauts home from the International Space Station. But this humble vessel contains something far more revolutionary than scientific data or space-grown crystals. It carries the first harvest from humanity's cosmic garden. Picture the scientists who carefully open this treasure chest from space. They wear clean white suits and handle the contents with the reverence of archaeologists uncovering ancient artifacts. But these metals are not ancient human creations. They are gifts from the cosmos itself, processed by the patient robots dancing among distant asteroids. The contents might seem unremarkable to casual observers. Chunks of metal that look like industrial materials you might find in any earthly factory. But each piece represents something unprecedented in human history. These are the first resources that humans have harvested from beyond our home planet. Word spreads quietly through scientific communities and financial markets. The first successful asteroid mining mission has returned its treasure to Earth. The age of cosmic abundance has begun not with fanfare and celebration, but with the gentle arrival of a small capsule in the desert dawn. Within days, the news ripples outward like waves from a stone dropped in still water. Investment funds that have waited years for this moment suddenly find their patience rewarded. Stock markets around the world respond to the reality that space mining is no longer science fiction, but profitable fact. Engineers and entrepreneurs who have spent decades preparing for this moment feel their dreams crystallizing into reality. The companies they have built, the technologies they have developed, the risks they have taken, all of these investments are validated by the quiet success of this first cosmic harvest. But the real revolution happens more slowly, in the minds of ordinary people who begin to understand that the resources of space are not infinite dreams, but tangible possibilities. Children look up at the night sky with new wonder, knowing that somewhere among those distant points of light, robots are working to secure humanity's future. The first cosmic gold rush differs dramatically from the earthly gold rushes of history. There are no crowds of prospectors rushing toward distant mountains with pickaxes and shovels. Instead, small teams of engineers send sophisticated robots across millions of miles of empty space. The timeline stretches across years rather than months. Where earthly gold rushes created boom towns overnight, the cosmic gold rush unfolds with the patience of astronomy itself. Mining missions are planned years in advance, launched when orbital mechanics allow, and harvested when the robots have completed their patient work. Picture the mission control rooms where this new kind of gold rush is managed. Engineers monitor screens showing the positions of distant asteroids and the progress of robotic miners. They are the new prospectors, but their claims are measured in astronomical units rather than acres. The wealth that flows from this cosmic gold rush is different too. Instead of individuals striking it rich through luck and determination, the treasures of space require massive investments and international cooperation. The rewards are shared among shareholders and nations rather than claimed by solitary miners. As more missions succeed and more treasure capsules return to Earth, the gentle revolution gains momentum. The prices of precious metals begin their slow decline toward abundance. Industries that have been limited by the scarcity of rare materials suddenly find new possibilities opening before them. Universities around the world establish new departments of space mining engineering. Students who once might have studied earthly geology now learn to analyze asteroid compositions from telescope data. The next generation of miners will work not in underground tunnels, but in the infinite tunnels of space. The environmental impact of this cosmic gold rush is the opposite of earthly mining booms. Instead of scarring landscapes and polluting rivers, space mining actually reduces the pressure on Earth's ecosystems. Mountains on our planet can remain untouched when their treasures can be harvested from mountains floating in space. Picture the gradual transformation of human perspective that follows this first successful harvest. For the first time in history, we become a species that obtains resources from multiple worlds. Our relationship with the cosmos shifts from observation to participation. The success of the first cosmic gold rush attracts new players to the field. Nations that have never had space programs begin to invest in asteroid mining technology. Private companies that once focused on earthly industries turn their attention to the treasures floating above. International cooperation becomes not just idealistic policy, but practical necessity. The vast distances and enormous costs of space mining make collaboration more profitable than competition. Former rivals discover common interests among the asteroid fields. The social implications unfold as gently as the economic ones. Workers in traditional mining industries begin retraining for jobs in space mission support. The skills of earthly mining translate surprisingly well to managing robotic operations millions of miles away. Small communities that once depended on local mines find new purpose as ground stations for space mining operations. Their expertise in extracting and processing materials becomes valuable even when the materials come from asteroids rather than underground deposits. The first cosmic gold rush creates its own culture and mythology. Children grow up hearing stories of brave robots traveling to distant mountains of treasure. Science fiction becomes science fact so gradually that the transition feels natural rather than shocking. Artists and writers find inspiration in the poetry of cosmic mining. They create works that celebrate humanity's expansion into the solar system and the patient harvest of celestial treasures. The aesthetic of space mining becomes part of human culture. As the reality of cosmic abundance becomes undeniable, deeper questions emerge about how this wealth should be distributed and managed. The success of the first missions proves that asteroid mining works, but it also raises profound questions about justice and fairness in an age of infinite resources. The gentle revolution sparked by that first capsule landing in the desert continues to unfold across decades. Each successful mission brings more treasure home and makes the next mission easier and more profitable. The cosmic gold rush becomes a permanent feature of human civilization. As you contemplate this quiet transformation of human destiny, consider how the success of space mining will require not just technological advancement, but wisdom in managing the abundant future that cosmic treasures might create, and perhaps most importantly, guardians to ensure that this wealth serves all of humanity rather than just the few who can reach it first. Picture shepherds watching over their flocks on a hillside that stretches beyond the horizon. But these are cosmic shepherds, and their flocks are not sheep grazing on earthly grass. They tend to robotic miners scattered across millions of miles of space, ensuring that the harvest of asteroid treasures serves all of humanity rather than just the wealthy few. These guardians of the celestial commons work from control centers scattered around the globe. In Houston and Moscow, in Tokyo and Paris, in smaller cities that have become unexpected centers of space commerce, dedicated teams monitor the patient work of cosmic mining. They are the watchers of the infinite pasture. The Guardians maintain databases that track every asteroid mining operation in the solar system. They know which robots are working on which space mountains, who sent them there, and what treasures they are collecting. Their computers maintain a gentle surveillance of the cosmic gold rush, ensuring transparency in the darkness of space. Imagine these cosmic shepherds as they begin each day by checking on their distant flocks. Screens display the positions of mining robots scattered throughout the asteroid belt. Status reports arrive at the speed of light, telling stories of patient work proceeding in the silence between worlds. The Guardians operate under international agreements that took decades to negotiate. Representatives from every nation on Earth contributed to the frameworks that govern space mining. Rich countries and poor countries, spacefaring nations, and those that have never launched a rocket, all have voices in the Cosmic Commons Authority. Picture the quiet diplomacy that makes this oversight possible. Former adversaries work side by side in mission control rooms, sharing information about mining operations that their governments might have kept secret in earlier eras. The vastness of space creates common ground between nations that have little in common on Earth. The Guardians use gentle tools to ensure fair play in the Cosmic Commons. They do not carry weapons or command military forces. Instead, they rely on transparency, cooperation, and the shared understanding that space resources are too valuable to be wasted on conflicts. When disputes arise between mining operations, the Guardians serve as neutral mediators. They help competing companies find ways to share valuable asteroids rather than fighting over them. They organize cosmic traffic to prevent collisions between mining robots approaching the same treasure mountains. The oversight system works through a network of agreements rather than a single governing authority. No nation wanted to surrender too much sovereignty to an international space government. Instead, they created a web of cooperation that spans the globe and extends into the depths of space. Picture the communication networks that connect these earthly guardians to their cosmic charges. Radio signals travel at light speed between Earth and the asteroid belt, carrying instructions to robot miners and status reports back to their human supervisors. The Guardians speak to their mechanical flocks across the vacuum using invisible threads of electromagnetic radiation. The Guardians maintain reserves of cosmic wealth that belong to no single nation. When mining operations extract more valuable materials than their sponsors need, the excess flows into international stockpiles. These reserves serve as insurance against future shortages and provide resources for global development projects. Small nations that cannot afford their own space mining programs benefit from the Guardians' careful stewardship. Portions of cosmic wealth flow to international development funds, supporting education, healthcare, and infrastructure projects around the world. The treasures of space become seeds of progress on Earth. The Guardians also watch over the robots themselves, ensuring that mechanical miners are treated as the valuable servants they are. When mining robots complete their missions, the Guardians help coordinate their return to Earth or their reassignment to new asteroids. No cosmic worker is abandoned in the darkness. Environmental protection extends beyond Earth's atmosphere under the Guardians' gentle oversight. They ensure that mining operations do not damage asteroids unnecessarily or create debris that might threaten other spacecraft. The cosmic environment is preserved for future generations of space explorers. The Guardians maintain detailed records of everything extracted from space. Every gram of platinum, every ounce of rare earth elements, every fragment of precious metal is tracked from asteroid to Earth. This cosmic accounting ensures that the benefits of space mining can be distributed fairly. Picture the training centers where new guardians learn to shepherd the celestial commons. Students study asteroid orbits and robotic mining techniques. They learn international law and diplomatic negotiation. They prepare to become stewards of humanity's expansion into the solar system. The guardians work in shifts around the clock, because space never sleeps. While some shepherds rest, others watch over the distant flocks of mining robots. The cosmic commons never lacks for careful attention and gentle oversight. Advanced computer systems help the guardians track the complex orbital dance of asteroids and mining robots. Artificial intelligence predicts when valuable space mountains will come within reach of Earth-based missions. Machine learning identifies asteroids that might contain unexpected treasures. The guardians share their knowledge freely with the scientific community. University researchers around the world have access to data about asteroid compositions and mining techniques. The Cosmic Commons Authority serves not just commerce, but the advancement of human knowledge. When new asteroid mining companies seek to join the cosmic gold rush, the Guardians help them navigate the complex web of international agreements. They provide guidance about which asteroids are available for mining and which are reserved for scientific study or international development. The Guardians also serve as early warning systems for potential problems in space. They monitor the health of mining robots and can recommend evacuations if solar storms or other space weather threaten mechanical workers. Their vigilance protects billions of dollars in cosmic investments. Picture the gentle satisfaction these guardians feel as they watch humanity's first tentative steps toward becoming a spacefaring civilization. They are midwives to a transformation that will echo through the ages, shepherding the birth of an economy that spans multiple worlds. The Guardians maintain libraries of lessons learned from each mining mission. Future expeditions benefit from the accumulated wisdom of earlier ones. Mistakes are shared openly so they need not be repeated. Success is celebrated and studied so it can be replicated. As the cosmic gold rush matures under their patient oversight, the Guardians begin to look beyond the asteroid belt toward more distant treasures. They study the moons of Jupiter and Saturn, planning frameworks for governing mining operations in the far reaches of the solar system. The work of the celestial shepherds continues quietly day and night, ensuring that the vast treasures floating in space serve the common good of all humanity. Their gentle vigilance makes possible dreams that once seemed impossible. As you drift deeper into peaceful contemplation of these cosmic guardians and their patient work, consider how their success in managing the asteroid treasure might plant the first seeds of something even more profound, an abundance so vast it could reshape the very foundations of human civilization. As you settle into the gentle embrace of sleep, picture the night sky above you filled with seeds of unimaginable abundance. Each point of light might hide an asteroid rich with treasures that could transform human civilization. These cosmic seeds drift patiently through the darkness, waiting for the moment when humanity learns to harvest their gifts. The seeds of tomorrow's abundance float in orbits that have remained unchanged for millions of years. They have waited through the rise and fall of countless species on Earth. They watched as our planet developed its first oceans, its first life, its first creatures to look up at the stars and wonder what lies beyond. Now, as you rest peacefully under their silent watch, these asteroid seeds are finally ready to sprout. Human technology has grown sophisticated enough to reach them. Our understanding of space has deepened enough to harvest their wealth. The cosmic garden is ready for its first harvest. Picture a child born 50 years from now, growing up in a world where scarcity has become a memory. This child might play with toys made from metals that once cost more than gold. She might attend schools built with materials harvested from the asteroid belt. Her world could be powered by technologies made possible through cosmic abundance. The transformation will happen so gradually that each generation will think their level of abundance is normal. What seems miraculous to us will be everyday reality to our descendants. The impossible becomes inevitable through the patient accumulation of small changes over time. Imagine cities where every building incorporates precious metals because those materials have become as common as steel and concrete. Streets might be paved with materials that today we can barely afford to use in tiny electronic components. The aesthetic of abundance will reshape human architecture and art. The seeds of cosmic wealth might eliminate the resource conflicts that have shaped human history. Nations will no longer fight over patches of Earth that contain valuable minerals. The treasures floating in space are vast enough to supply every country's needs for thousands of generations. Picture the research laboratories of tomorrow, where scientists work with unlimited supplies of rare materials. Experiments that are impossible today because of cost will become routine. New discoveries will bloom like flowers in an endless spring, fed by the cosmic abundance flowing down from space. Medical advances might leap forward when precious metals become abundant enough for widespread use. Devices that today help only the wealthy could reach every person on Earth. The healing power of advanced technology could spread as widely as sunlight. The environmental healing of our planet might accelerate as mining operations move from Earth to space. Mountains scarred by centuries of extraction could be allowed to recover their natural beauty. Rivers polluted by mining waste could run clear again. The Earth could become a garden tended rather than a resource exploited. Children in this abundant future might grow up with a completely different understanding of value and scarcity. They could learn to treasure creativity, kindness, and wisdom rather than rare materials. The things that truly matter might become more precious as material wants become easily satisfied. The seeds of abundance drift through space in predictable patterns, following laws of physics that never change. Scientists can calculate exactly when each asteroid will pass close enough to Earth for harvesting. The cosmic harvest follows a schedule written in the stars themselves. But abundance brings its own gentle challenges. Societies that have organized themselves around scarcity will need to learn new ways of living. Economic systems built on the assumption that valuable things are rare will need to evolve. The transition might take generations to complete. Picture the artists and philosophers of tomorrow contemplating what it means to be human in an age of unlimited material wealth. They might discover new forms of beauty and meaning that we cannot yet imagine. The human spirit might find new directions for growth when material needs no longer dominate our attention. The cosmic seeds above you carry more than just metal and minerals. They carry the potential for humanity to become something greater than we have ever been. They offer us the chance to solve problems that have plagued our species since the beginning of civilization. Imagine the space elevators and orbital habitats that might become possible when building materials are no longer expensive. Humanity might spread throughout the solar system, carried by the wealth extracted from the asteroid belt. We could become a truly spacefaring civilization. The patient robots already working among the asteroids are planting the first seeds of this abundant future. Each gram of precious metal they extract brings us closer to a world where scarcity becomes choice rather than necessity. Their quiet work in the darkness prepares the soil for tomorrow's harvest. Educational systems might transform when every school has access to unlimited resources for teaching and learning. Students could work with the finest equipment and materials from their earliest years. The development of human potential could flourish without financial constraints. The seeds of abundance include more than just material wealth. They carry the potential for international cooperation on a scale never before achieved. Managing cosmic resources requires nations to work together, creating habits of collaboration that could spread to other areas of human endeavor. Picture the gentle revolution that unfolds as these seeds germinate over the coming decades. Each successful asteroid mining mission plants more seeds of abundance. Each technological breakthrough brings the harvest closer. Each international agreement tends the growing garden of cosmic wealth. The transformation might be so gradual that people living through it barely notice the changes. Like the slow progression of seasons, abundance could arrive so naturally that each generation simply adapts to their new circumstances. The miraculous becomes mundane through gentle familiarity. Yet some aspects of human nature might remain unchanged even in an age of cosmic abundance. We might still seek challenge and adventure, purpose and meaning. The seeds of abundance could free us to pursue these deeper treasures with unprecedented focus and energy. The night sky above your resting form holds more seeds of transformation than all the gardens that have ever grown on Earth. Each asteroid represents possibilities that stretch beyond our current imagination. They float patiently in their orbits, ready to sprout when the time is right. As your consciousness drifts toward the peace of sleep, let the knowledge of these cosmic seeds comfort your mind. Tomorrow's abundance already exists, waiting patiently in the darkness above. The future wealth of humanity circles the sun in predictable orbits, as reliable as the sunrise. The seeds have been planted by billions of years of cosmic gardening. Now they wait for human hands to tend them, human minds to understand them, and human hearts to share their abundance with all the world. Sweet dreams of cosmic harvests drift gently through the infinite darkness, carrying promises of plenty yet to come.